Okay, we are live. Hello, everyone. I'm just going to wait a bit for some more people to join, and we'll get started. I'm just going to go ahead and share my screen while I'm at it. Okay. All right. Yeah, just give it like maybe another minute, and then we'll begin. Link to STEM fellowship as well. All right. Okay, sorry, just one moment. We'll begin shortly. Okay, that's fine, I guess. Sorry, just 1 sec. I'm just going to try to see what I can do to make it shorter. Okay, that's fine. Okay, everyone. Oh, sorry about this. All right, so I guess we can get started. So hello and welcome, everybody. So this workshop, let me just expand my screen a bit. So yeah, welcome to this workshop. And this workshop is intended for individuals with no coding experience. So we will be looking today into intro to data visualization with Python. I did an earlier workshop today for like slightly more proficient programmers. So this one is like for people who have less proficiency in programming or like hardly no experience in it, which is fine. I'll put the links to both of these. I put them in the chat here, and I put the links to both of my notebooks that I worked on in both sessions in my bio here on Crowdcast, so you can just see that. I put the links here, as well as my LinkedIn if you'd like to connect with me there. But yeah, let's get started. So, like I said, this will be a gentle introduction to data visualization with Python. So nothing too hectic or anything like that. In Python, we have access to a feature, should I say, called a library. So you'll be seeing this throughout like this notebook as well. So what a library is in Python, it's just it gives us the capability to do many things, particularly in this case, to manipulate data. So yeah, to manipulate it in different ways and visualize in different ways. So today I'll be introducing you to one of the most widely used data visualization libraries in Python. It's called matplotlib. So it's like an array of tools that we can use to like help us plot things in graphs and whatnot. So yeah, it's called matplotlib. And the matplotlib package is a library for creating two-dimensional charts and graphs. If not already installed on your system, you can enter the following code on your command prompt window to install it. If you have a Windows system, you'd put in this pip install matplotlib. For Mac or Linux system, you would write in this code here. And once you enter the command and the downloading process is finished, you can enter the following command below, which is just this here. So what this does is that this imports this library as MPL. So when we say as MPL, we're essentially just nicknaming it or just giving it a different name, so that when we have to refer to it every time we do a command, we don't have to write out matplotlib because it's a bit of a hassle. We can just write MPL because this is like an alias or a different name for this. So we give like matplotlib a nickname of MPL. That's what that means. Next, we import the pyplot module. So the matplotlib package contains a module named pyplot that you will need to import in order to create all of the graphs that we want to demonstrate. So within the library, there are a bunch of different tools, and one of those tools is called pyplot that we're using to help us plot these things, right? So you can think of it like a scripting interface, for example. So this is how you would import that module. So once you have done this, you would then do this. So you would import matplotlib.pyplot, and then we give it another alias or a nickname as PLT. So we don't have to write this thing out every time because it's a bit of a hassle. So once we've done these two things, we're good to go. We've imported what we need to import. We have all the tools at our disposal, and now it's up to us to use those tools. So we also have the plot function, which you will see. It's going to pop up a lot here. This is for when you want to like plot various things to your graph, but I'll get into that in just a second. So we have the plot function, which is what we use to pass in arguments and it's like we pass in arguments and parameters. So like characteristics of what to do, like what we want the graph to show. So then it will know what to plot. So it's actually just down here, and I'll just go over this like just a bit after. But so I have plot here, and this is essentially where like the plot function is where everything comes together so it can then be plotted. So like, for example, yeah, like, and those things are called arguments or parameters. And there are many functions associated with PLT, like the scripting interface, like title, grid, label, and so on. But yeah, let me get into like what this all means. So starting off with an example. Example one, we'll plot a line graph in matplotlib. So let's say we have the following list of points for which we want to make a line graph, right? We have these coordinates here, and we want to make it into a line graph. So I first have to do these two steps, this one as well as this one. And once you write it here in the notebook, I should say you don't have to write it for every visual. Like, it's in the notebook, it's been run, the cell has been run, so it's good. But just to reiterate like how like it affects this, I will just show you again as well. No big deal. You can put it twice or many times, it doesn't make a difference. As long as it's there once in the notebook, it's fine. So I import matplotlib as MPL, and its scripting interface is PLT. You have to do this whenever you want to plot something with matplotlib. And now I create lists with the x and y coordinates of each data point. So of these points here, so I separate the x's and the y's. You can see I have the x's 0, 1, 2, 3, 4, and then the y's 0, 3, 1, 5, 2. So I split them up into two different arrays or lists, if you'd like. And what I'm going to do now is I'm going to add a title. And so you know how I mentioned there are many other functions associated with PLT, like, for example, title, grid. So this is one of them, right? So we want to add a title. We have to specify, first of all, we recall the scripting interface, and this is why we call it PLT, because if we didn't, we'd have to write this every time instead of PLT, so it's kind of a bit much. So yeah, we just write PLT just for short, which is nice. And then we have to specify what we want to do. So we want a title, so we have to put .title. And then you can put the name of the title here, anything you'd like. I can say, this is our title. Just run the cells. And you can see here, it updated, right? This is our title. So the title can be anything you want. So it's pretty standard there. And next, we can also add labels to the axis. So you can see here, again, I have to refer to the scripting interface PLT for the axis. And then we have a method called .xLabel. This allows you to label the x-axis, and I can call it whatever I want. I said this is the x-axis. And then the same thing for the y-axis. The method is called .ylabel. And then I just write, this is the y-axis. And I can change the name to anything I want. So I can put like sales value, for example. And I could also write year. Sorry, no, other way around, actually, it should be. I'll put like year for X and then sales for Y. And the titles of the axes will change. You'll see when I run it. See, it's year and sales now. And another thing, so these are just more aesthetic related things. Like I can add a grid, for example. I just put plt.grid. I use the grid method, and I just put true. So this gives us like grid marks in the background, just makes it look a bit nicer. And then I can customize the tick marks on the graph as well. So you can see like before for the X and Y coordinates, I had like we had 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5. These are obviously the data points, like they correspond here. So it starts over here, 0, 0. That's because I made this change, but I'll get into that in just a sec. So we have the data points here, 0, 0, 1, and 3, 2, and 1, 3, and 5, and 4, and 2. But instead, I can assign these, and because these are the same things that we have here, you see, I have the X ticks laid out, which is the same as the X coordinates. Sorry, no, excuse me. So I have the X, so this is for the graph. So I have the X ticks laid out like 0, 0, 1, 2, 3, 4, and then for the Y ticks, 0, 1, 2, 3, 4, 5. But instead of just having these numbers as the ticks, I could also assign them a value, right? So here I put, I changed them to 2016, 2017, 2018, 2019, and 2020. So I'm just going to say that I'll hold all questions to the end. So if you have a question, feel free to write it in the chat, and I can go back to it when we finish. But yeah, so that's pretty standard there. It's just corresponding each one of these, like the 0 becomes the 2016, the 1 becomes the 2017, and then 2 becomes the 2018, and so on. So I just labeled them more nicely. And then same thing here for the Y, for the 0. It becomes a 0 million, and then for the 1 value, which is here, I put it as 1. For the 2 value for Y, I put it as 2 million, and then so on, right? So pretty standard there. And then I set the axis limits, and this is why it looks a bit weird and why maybe it doesn't look like it starts at 0. Because I put like the limits. So again, we have another method here, xlim, for the limits for the x-axis. I'll just say limits for the x-axis, and then we have the same thing for the y-axis. So the limit for the x-axis, for the minimum value, it starts at -1, which is here, and our data point is 0, 0. So we start at -1, which is this line here, and then we go until 5, which is so we go 1, 2, 3, 4, 5. We end here. And then we have -1 for y, so in 0 we have -1 for y. That's where the graph sort of starts. And then 1, 2, 3, 4, 5, 6, and then there you go. So that's the limits for the x and for the y. All right, pretty standard there. And you can also change this. Again, you don't even have to have this in. Like it's just optional, but if you want, yeah, feel free. If not, then you can remove it. It's fine. You can change the numbers to what you like. So we build the line graph, and then again we use the plot function like I mentioned. This essentially sort of takes in all the arguments that we made, like the x coordinates, so it knows what to plot exactly. And then we have the marker. I can specify a marker for each one. I just put 0 and a color red. And then to show the line graph, we have to do plt.show. So yeah, and to know what arguments go in, like what's actually like what this thing needs to know to be plotted, if you just click this, or I think if you just hover over it, you can see like some of the arguments that belong in here, like a scale, the data, and whatever else, right? Like there are many different arguments that I passed in, so they're essentially like things that need to be clarified in order for this to be plotted. Okay, I think that's good though. So pretty straightforward for the line graph. And now example 2, we're going to plot a bar chart with matplotlib. So similarly for the line graph, we will create 2 lists, one containing the x-coordinates of each bar's left edge, and another containing the heights of each bar along with the y-axis. The reason why we do the left is because so we know like where the bar starts, not in the middle. We want the bar to be placed at a specific marker along the x-axis, so that's why we indicate the left side. And then we have to obviously indicate the height or the y value, so we know how high we're going, right? So conveniently, we have a PLT or a plot.bar function for plotting a bar chart, which I will explain more below. So again, same thing. I already imported these in the previous example, so I don't really have to do it again. It doesn't really make a difference. So that's all good there. And then, like I said here, I create a list with the x-coordinates of each bar's left edge. So the left edges are 0, 10, 20, 30, and 40. Those are the left sides of the bar where they start. And then I create a list with the heights of each bar. So this bar number 1 corresponds to like the start value of this. So this is going to be 0. Sorry, for when we're at x is 0, y will be 100. When we're at x is 10, y will be 200. When we're at x is, like the x value is this, or like a tick along the bottom, I mean, we go to this value and so on, right? So these are the heights corresponding with each x-axis for the bar. Next, again, more aesthetic related things. We can create a variable for the bar width. So I just put 10 here, but like, for example, I could also put like 5 if you just want to see, and it would look like this, right? This does kind of skew the bar width a bit because we've made it like this. So I guess I can just like shift this over. But again, like, yeah, like it's basically up to like your own judgment if you want, like if you want to decide how it looks. Just keep it at 10, just to not have gaps in between the bars. But yeah, then you can just like change where the left edges start. Essentially, that's what we're doing this with this column, just shifting them over and whatnot. And then we build the bar chart. So similarly, like a line graph, we pass in a bunch of arguments or just things that are needed in order for us to build the chart, right? So this function needs to know, all right, what do I need to build this chart? I need to know the left edges, where it starts. I need to know the height, how high I'm going to go, the bar width, how thick it's going to be. And also I passed in another one, just so you can get a taste of what it looks like, a color parameter. So we specify the color of each of the 5 bars. So there's 5 bars here, and you have to have the same number. Or if you just want to put one color, I can put like red and just have it one color for all of them the same. But here I assigned each bar a color. So the first one's red, this is green, this is blue, this is yellow, and this is the code for black. It's just the letter K. And that's what corresponds to here. So next we add a title using the plt.title method. And this was the sales, excuse me. So sales by year. And then we add labels to the axes. Yeah, so you see the title there, sales by year. Just run that again. So now it's updated. And then we add labels to the axes. We have year and sales. And then similarly, what we did before with the tick marks here, we could also customize them here as well. So essentially, I assigned a value, like at each of these tick marks, 5, 15, 25, 35, 45. I gave them the values of this. So at 5, you'll see 2016. At 15, you'll see 2017, and so on, right? Same thing for Y, for the values that were given here. I just assigned them tick marks as well. You don't have to make them the same, I should know. Like, it's just like, so they kind of align, which is why when I changed the bar width, you saw it was a bit like shifted, because now like I plot the ticks like 5 units to the right. So you can see like, which is why it looks a bit offset, but that's fine. Again, you can just like change this to whatever you want, just so they match up. It's no big deal, really. And yeah, same thing for the Y. Obviously, you want them to match the height. So for like 0, it's 0. For the 100 one, which is this, we have 1 mil, which I specify. 200, the green, I have 2 mil, and then so on, right? So again, that's pretty straightforward there. And then, yeah, we just show the bar chart with plt.show. You have to do this to show the actual chart. This will make all of the changes. This is all like the back end stuff, and this is like the front end stuff where it actually shows the chart. And yeah, here's our chart. Example 3. So I'm going to be plotting a pie chart with matplotlib. To plot a pie chart, so we can use the plt.py function, which similarly we saw with the bar. It had its own, where you pass in a bunch of parameters and whatnot, things it needs to know to be plotted. So we can use the plt.py function in the matplotlib.pyplot module. And similarly to the bar charts and line charts, and yeah, like I just mentioned, when you call the py function, you pass a list of values as an argument. Values are things like the data values, the labels, colors, things like that, just the little characteristics for the visual. The py function will calculate the sum of the values in the list, which is here in this case. So I'll just go over that in just a sec. So it calculates the sum of the values in the list and then uses that sum as the value of the whole. And then each element in the list will become a slice in the pie chart, right? So let's say we have the following values, right? We have 20, 60, 80, and 40, right? So the sum of the list elements is 200 when you add all these up. So that's the total. So the pie chart's whole will be 200. So each of these will be divided into slices over the whole 200. So there are 4 elements in the list. So the pie chart will be divided into 4 slices. These are the 4 elements in the list here, and I've also written them here. The 4 different like data values. I'll just scroll down so you can see the 4 different ones on the visual. So the first slice represents the value of 20. So it will be, so it will be 10% of the whole, because 20 out of 200, the sum is 10%. The second slice will represent the value of 60. So it will be 30% of the whole. The third slice will represent the value of 80. So it will be 40% of the whole. The fourth slice represents the value of 40. So its size will be 20% of the whole. Pretty straightforward, right? We're just proportioning the slices for each part of the pie chart according to what the values are over the total. So let's see how that looks. So again, we import this as a scripting interface. We create a list of the values that we're looking for, which is these here. We create a list of labels for the slices, so they correspond accordingly. So we have slice labels. So this will be the first one, second one, third one, fourth one. And then we create a pie chart from the values. So again, we pass in this method. And you can see here when I just hover over, there are a bunch of little parameters. Like you see X, explode, labels, colors, a bunch of things, right? So these are different parameters that we pass in just to sort of like change the way the visual looks and really like make it detailed the way we want it. So I pass in values because it needs to know what values to plot. I pass in labels, which is I equal, because you can only pass in labels as a parameter. You can see labels here. So I had to denote labels as slice labels, just so it knows. And then I pass in colors as well. Colors are equal to this. So it knows to match them up accordingly because I have the same amount, 4 in this, 4 in this, and 4 in this. And I'll match it up the way it's ordered, right? And yeah, so colors, again, I pass in. Again, for colors, you probably don't want them all the same for a pie chart, so it's kind of hard to distinguish the slices, but you can do that if you like as well, it's fine. And then I will add a title. So then I just do plt.title, I give it a title, and then I show the pie chart. And that's pretty much it, really. That's that for pie chart. And yeah, that's really much what I had planned for this. A bit short, but more of like an introduction. But just to, honestly, just to give you guys a little introduction to data visualization in Python. I didn't want to overwhelm you with too much or to anything too crazy. So hopefully, like, this is a good place to start. I feel like it is for sure. Matplotlib is definitely a good place to begin. it's like I said, the most widely used data visualization libraries in Python. So just knowing some basic visualizations will really help. And one thing that I felt really helped when like I was starting out with this was that like really just playing with it, really just playing around with it. Here I can play around with like the tick marks, the data values, the colors, and just seeing how it really all is integrated into each other and how it all looks and how it all works. So yeah, I hope that was helpful. And once again, I shared the notebook here in the chat here, so you can click on it. It's also on my profile as well. The links to my other notebooks. For those of you that joined late, I did an earlier workshop today where I did data visualizations, but with people who had more experience in Python or more proficient programmers. But yeah, you can check that out if you want like a challenge or something like that. But I recommend like if you're not familiar with like concepts like data frames and pandas, then maybe it might be a bit hard to understand. But yeah, no, feel free to check it out. It's actually this over here. It was like a lot more complex. But yeah, that's pretty much all from me. I'll stay around for any questions if anyone had anything they'd like to ask. Oh, thank you. I'm glad you enjoyed it. Yeah, definitely a good place to start for people who don't have a lot of programming experience. If you do want some programming experience, I would check out this site. I'll just leave it here. Also, I should mention briefly, so the organization that I'm a part of, STEM Fellowship, I put a link to it here. I couldn't put it in my bio because it's too long, but I put it here in this chat if you want to check it out. Basically, what we are is that we are a student-run nonprofit organization. We're based in Canada, but we operate like around the world essentially. We're not only restricted to Canada, so it's not a problem for the American viewers here. But what we do is we run competitions and interdisciplinary learning for different various fields of STEM. Like we have physics tournaments, scholarly writing, data science is one of them, hence why I'm here today. And what we do is we run both undergraduate and high school big data challenges. So what that is like we essentially give you resources and tools like this that I've presented here to you, sort of at an intro level, maybe a bit more of a grasp on Python than this, but this is just a good place to get started. We teach you everything you need to know essentially for competing in what we call our big data challenge. And what the big data challenge is that once we've given you all these resources and workshops and everything else, we then pick a theme. That could be maybe climate change, economics, COVID-19, etc. And we want you, the student, to present to us a solution to a problem that you found. You can come up with the problem that you want as long as it's in the field that we assign to you, like the topic. Like if it's relating to COVID, if that's what we give you, then it has to be something along the lines of COVID. But you can decide whatever it is that you want to do as long as it's related to COVID, which is fine. And then once you do that, you get, well, for the high schools and undergrads, it's different, but for the high schools, you get about 2 months to work on a project using the methods we've given you, various tools in Python, etc. And we give you sample data sets as well. You put together a report, and then you present the report, and then we will select the best, like it could be 5 or 10 contestants, whatever it is, for a finalist round. So then you present to a panel of judges, and then yeah, from there you have a chance to win. We do offer some incentives as well and prizes, publishing in our STEM Fellowship Journal, internship opportunities for the students, and a cash prize as well. So definitely something to check out. The link is right here. Just you can type in like STEM Fellowship in Google and it would show up, I assume. But that's really yeah, what I wanted to say about STEM Fellowship. And yeah, like that's I guess all from me. Like I said, I'll stick around for any questions. But yeah, thank you all for watching, and I hope you really enjoyed. No problem, Morgan. Thank you. I'm glad you enjoyed. I'm glad you guys enjoyed. No problem. Thank you, John. I'll for sure keep this in mind. Appreciate that. Just open up the link so I don't lose it. I guess maybe I can end the session then. If there are no more further questions, I'll just wait like a minute or so.